So since we saw how interest works on a compounded monthly basis and compounded yearly basis, we're going to do some comparisons right now. We're going to compare the formulas for the yearly interest and the monthly interest. What you see here is that when you do this thing yearly, if we let t be the years, basically our exponent is a t. If we do this monthly, it's a 12t. And our rate, if I do it yearly, it's once per year, so it's just the rate itself. If I'm doing this monthly, it's 1/12 of the actual rate that we're gaining in interest. So now there's a basic idea. If I didn't want to have a yearly or monthly, what if I wanted to compound this 4 times? Well, if you want to compound this 4 times, then you can use this formula. And basically all you're doing is replacing the 12 with an arbitrary number. So anytime if you want to compound 2 times per year, 3 times per year, 15 times per year, 110 times per year, all right, whatever that m is, you're just going to divide the rate by the m, and the exponent is becoming an m times a t. Now again here, t is the number of years. So we're seeing if you compounded 100 times per year, and if you did 2 years, then really we've compounded it 100 times 2, or 200 times. So let's do some comparisons here. And the first comparison is going to be what's going to happen when the starting amounts differ. Okay, in fact, most of the things in here I'm going to double. Starting, in this particular case, I'm doubling the starting amounts. So, the important parts of this, there's 2 problems here, is that you begin with $2,000 and you're going to have 6% interest compounded yearly for 15 years. This is my original setup. So, as per the formula, you're taking 2,000, 6%, since it's yearly, it's just 1 plus 0.06 for 15 years, so my exponent is 15. All right. If we change the starting amount to 4,000 instead of 2,000, then I have 4,000 times 1 plus 0.06 to the 15th power. And you can calculate both of these. Now once you calculate these, you'll see that the first one, if you started at 2,000, gives you a total of $4,793, and in this case, 12 cents. With 4,000, you get $9,586.23. So, the interesting observation is that if the starting amounts differ, then basically what we have is we have the ending amounts are differing by the exact same ratio as the starting amounts differed. So in fact, if you look at the difference between 2,000 and 4,000, that's double. You've doubled the amount going from 2,000 to 4,000. And in fact, going from 47.93 to 95.86 is also double. Now there's a penny difference because of rounding issues, but it is double. Okay? And also, just to make this point clear, the amount of interest is double as well. Okay, in fact, it's exactly double. In this first case, the one we had 2,000, if you take 47.93 and 12 cents, subtract the 2,000, you'll see that as far as interest goes, that was 93 and 12. That's the amount of interest. And the amount of interest in the second one is $5,586.23. So not only did the amounts double, but the interest is actually doubling. Okay, and remember, the interest is what's causing, or excuse me, is how it's growing. It's growing by interest. So what we're going to do is we're going to do this, and we're going to sort of vary the different options that we can vary. Okay, so the first one I'm going to do is we're going to compound things at a different rate. So the difference between these two examples, we're still going to start at $2,000 at 6%, but now we're going to compound monthly for 15 years versus compound quarterly for 15 years. I want you to try and calculate these two and see what kind of answers you get, and also what kind of observations about how fast things are growing and how these work differently. So push pause, and I'll give you a few seconds, and then I'll state it. So again, hopefully you push pause and did that. I'm going to do this fairly quickly. So $2,000, if we're compounding monthly, we're going to take 2,001 plus 0.06 over 12. 12 months for 15 years, that's an exponent of 180. The next one is 2,001 plus 0.06 divided by 12. If it's quarterly, that means, quarterly. Quarterly means 4 times a year, not 12. And since we did it 4 times per year for 15 years, that's 60 as my exponent. Calculating that, you'll see that compounding monthly gives you a final amount of 4908.19. And compounding quarterly gives you a final amount of 4886.44. So there is a difference in compounding quarterly and compounding monthly. And by the way, if you recall compounding yearly, what you see is that the more times you compound interest per year, the more you're going to get. Although it's not the case. I mean, monthly is compounding at 12 times per year, and quarterly is compounding at 4 times per year. So it's not the case that you're going to double if you double the amount of times. In fact, you are gaining, but the amount of gain isn't a huge gain. It's in this case less than $30. Okay. So it's not going to be a huge gain, but it is going to be a gain. So let's do the rates. Let's differ the rates, and we're going to double the rates. So we're going to start at 2,000, and we're going to compound at 4% monthly versus 2,000 at 8% monthly for, again, 15 years. So again, push pause on the video. Try to work this out by hand, and then make some observations on your own. All right, hopefully you've made those observations by now. And I'm going to, again, go through this fairly quickly. So if you begin with 2,000 at 4% interest, compounded monthly for 15 years, that's 180 is my exponent. 2,000 compounded monthly at 8%, 0.08 for 15 years. Those are the setups, so type that into your calculator. You'll find that you get out $3,640 roughly, 640 and 60 cents in the first case, and in the second case you will get out $6,613.84. By the way, if we're talking about interest, the interest that you got out in the first case was 1640.60, and the interest that you got out in the second case was 4613.84. Excuse me, 84. Okay. Now this is a big deal because it's not just double the amount like it was when we talked about your starting rates are double. Here we get more than double the interest. And in fact, any time that the rate is going to double, we're going to get more than double the interest. And any time the rate triples, no matter how much time has passed, we're going to get more than double the interest. Okay? So that is more than double the interest if the rates double. Okay, so if rates double, so if rates are 2 times each other, you get more than double the interest. And by the way, if rates were 3 times each other, then you get more than 3 times the interest. If the rates were 5 times each other, you get more than 5 times the interest. And so differing the rates has a bigger effect on interest, on at least the scaling of the interest, than does the starting amounts. The last thing we're going to adjust is the time. So I want you to read these things, read these 2 examples. We're going to, in essence, double the time. We're going to go from 10 years to 20 years. I want you to calculate these. Again, push pause on the video, calculate them, and then come back. So hopefully you've done that. Let's do these setups. 2000. All right, 6% interest compounded yearly. 1 plus 0.06, I divide by 1. I don't really need to push the divide by 1. For 10 years. 2,000, 6% interest, compounded yearly, for 20 years. So we'd plug that into our calculator. And you would get out a total of $3,581.70 if we waited 10 years. And if you waited 20 years, you would get out a total of $6,414.27. Now again, let's examine that for interest. If I do the interest, that's going to be $1581.70 versus interest over here is $4414.27. So notice here, we get the same kind of situation as when the rate differed. We doubled in time, and the amount of interest was more than double. Okay? So, if time is doubled, then interest more than doubles. And by the way, the exact same thing would happen if we tripled the time. If we tripled the time, then the interest would more than triple. So we should take away from that time and rates. Obviously, if you double them, your interest is going to more than double. If you doubled the starting amount, then you get exactly double the interest.